Today we'll be discussing these identities in the chapter of trigonometry. Now this can be quite confusing to some of you guys, so let me go through a lesson proper to explain to you. Now let us do some investigation. Now I'm not going to prove to you, but I'm going to go through some investigation, all right, so that you understand the thing better. And on your own, you can try it out. Now let's take an angle, say an angle of 30 degrees. So this is 30. Now, what are the angles that has a basic angle of 30? Now, what is a basic angle? A basic angle is the acute angle that is made with the x-axis by the actual angle. Now, let's say this is the actual angle, right? From here to here is the actual angle. Then here will be the basic angle made with the x-axis. So this is another 30, all right? So this angle here is another basic angle. It's an acute angle that makes with the x-axis. And this is another basic angle, or sometimes you call it reference angle. Now, if this angle is 30, what other angles will have a basic angle of 30? So let me write it down. Let's say this is 30. All right. Now another angle that has a basic angle of 30 will be this angle here. All right. Now this must also be 30. Now, then the other angle will be 180 minus 30. All right. So I got 150. Now, what is the other one? The other one will be this one. All right, up to here. Now this angle is 30. So the other one will be 180 plus 30. So it's 210. Now how about the last one? Now if this angle is 30, then the actual angle will be all the way from here up to here, and that will be 360 minus 30, and that gives us 330. So if I give you any acute angle, right, so you use 180 minus the angle and 180 plus the angle and 360 minus the angle, all these angles will have a basic angle of 30. Now what happens if instead of giving you an acute angle, I give you some other angle that has a basic angle of 30? Now let's say I give you an angle that is in the fourth quadrant. Okay, let's go through this procedure, see whether we will get the angle, all the angles that's within 0 to 360 that has a basic angle of 30. Now, let's say we do this first, all right? We use 180 minus 330. For that, we get minus 150. Minus 150 is this way, all right? This direction. Then you use 360. Then you plus 360 to it, okay? Then you get what? 210. So you get this angle 210. So you get an angle of 210, which also has the basic angle of 30. Now we are using 330, okay? Now then, let's try this. 180 plus 330. You got 510. Now 510, if you subtract 360, all right, you get 150. So you still get, the other angle that also has an angle of 30. And the last one, all right, we use 360 minus 330, you get 30. All right, you get another angle that has a basic angle of 30. Now what I am trying to tell you is, now no matter what angle I give you, all right, let's say I give you angle A. What are the other three angles that also has a basic angle that A has? Let's say A has a basic angle of alpha. What other angles, all right, what other four angles that also has a basic angle of alpha? So you find that the four angles are 180 minus A, 180 plus A, and 360 minus A. So all these will have the same basic angle that A has. If A has a basic angle of alpha, all these angles will also have a basic angle of alpha. Now let us name all the four angles that is in the first, that is in the four quadrants that has a basic angle of 20 degrees. So what are the other angles? It will be 160. You use 180 minus 20. Then you use 180 plus 20. There will be 200. And the last one will be 340. These four angles are angles in the first four quadrants that has the basic angle of 30. Now let's press a calculator. Let's put sine 20. And then you sine, same thing, you sine all this angle. Okay? And then you have sine 200. And then you have sine 340. Okay? Now let's press the calculator and see what value does it give us. Now I already pressed, so I already know, not that I memorize it. Okay, so this is 0.342. Okay, now just press, you notice what will you see? 0.342, 0.342, 0.342. Now, some of them will have a positive sign and some of them will have a negative sign. But we are not talking about that first. You notice all of them have the same numerical value. That means it's not a proof, alright? It's just some investigation. I'm not proving to you, alright? So I find that you'll understand better if I show you real examples like this. So that's why I'm doing it. Now, you find that all this angle has the same numerical value. When I say numerical value, that means I disregard the sign. But some of them have positive and some of them are negative and some of them are positive. Now, you look at it, now you learn in school that this thing, all angles or all the trig functions are positive in the first quadrant, sine, cosine, tangent. And in the second quadrant, sine is positive. Third quadrant, tangent is positive. Last quadrant, cosine is positive. Now, so you look at this. Sine 20, so is in the first quadrant, so this is positive. This is in the second quadrant, so sine in the second quadrant is positive. Sine in the third quadrant is negative. Sine in the fourth quadrant is negative. Okay? Now let's try some other trig function, see whether is it true. So let's do tangent. Tangent 20 you get 0.364. Then let's try tangent 160, tangent 200, and tangent 340. You've noticed that all of them give the same value of 364. 0.364, I mean. But some of them will be positive and some of them will be negative. Look at it. First quadrant, this is positive. Second quadrant, tangent is negative. Third quadrant, tangent is positive. And fourth quadrant, tangent is negative. Now the point I want to stress is, I think most of you don't have the problem in the sine, but the thing I want to stress is, if they have the same basic angle, then you realize that they will have the same numerical value if we disregard the sine. Now, so we come to these identities here. Now you look at this, all these are definitely equals to each other, except the sign we are not sure whether which quadrant are they in. Okay? Now, these are identities, they are not. What is the difference between identities and equation? You'll find that an identity is true for all values of the equation, alright? The expression of the equation. Now, example of an identity is 3x is equals to 2x plus x. This is an identity. This is true for all values of x. Now, if I put 2x plus x is 6, this is not an identity, this is an equation. Because this is only true when x is 2. Okay? Now, so if since the formulas are wrong, some of them, okay? Now, but never mind, I will slowly come to that. Now, since all these are identities, and they are true for all angles, then if we want to determine they are positive or negative, then it will be easier if we choose an angle that is in the first quadrant. But it really doesn't matter which angle you let A be, alright? But I'm saying that it is easier to imagine if you put A as a first quadrant. Even you put A as a third quadrant, second quadrant, or fourth quadrant, alright? If you analyze it properly, it will still be the same. But for simplicity, we take A as first quadrant, alright? That will help us a lot. Now look at this. If sine A is in the first quadrant, so all these are first quadrant, all these are A in the first quadrant. This will be in the second quadrant. So sine is positive in the second quadrant. So this is a positive. Now look at this. This is positive. Sine A is positive. This is in the third quadrant. So sine is negative in the first quadrant. So to make it equal, this is minus. Alright, this is, if this is A is first quadrant, this is last quadrant, alright, or fourth quadrant. If it's fourth quadrant, then sine is negative. So to make it equal, this has to be negative. Now 360 minus A is same as minus A, okay? So this is minus also. Now we come to cos. Now if this is in the first quadrant, this is in the second quadrant. So to make it equal, we put a minus. This is first quadrant, this is third quadrant, and cos is negative in the third quadrant. This is positive in the first quadrant. So I must have a negative sign. So this is in the fourth quadrant, this is in the first quadrant. Cos is positive in the first and the fourth quadrant. So it's positive. Alright, if it's positive, I will not write anything. Now how about this? This is, now if this is the first quadrant, this is second quadrant. So second quadrant, tangent is negative. So this is, to make it positive, Alright, as to be equals to this, I have to put a negative. Alright, so this is okay. The rest I will just fill up. You can try to analyze it on your own. Okay. Now, so you find that you don't really need to memorize these formulas. Okay, you can actually deduce. Okay, let's say they give you cos A, cos 180 minus A. So whether it's positive or negative, you look at if this is in the first quadrant, this is in the second quadrant. So to make them equal, one of them must be negative. Okay, we will learn what are complementary angles and what are complementary trig functions. Now, what is complementary angle? Now, two angles are said to be complementary if they add up to 90 degrees. Example, 30 and 60 are complementary. Alright, 30 and 60 degrees are complementary. Why? Because they add up to 90. Now, must this be in the first quadrant or must it be positive? No, not necessary. I give you an example. If let's say this is minus 20 degrees and this is 110 degrees, these two are complementary also. So it doesn't matter as long as it adds up to 90. Then the two angles are said to be complementary. So you always hear from your teachers or hear from your friends that sine and cosine are complementary trigonometric function. What do you mean by that? Now that means sine A will be equals to cos 90 minus A. Now when these two are complementary angles, then sine of this angle and cos of this angle, you will get the same answer. You can try that out. Take for example, you can press a calculator, all right, to verify this. Sine of, say, minus 120. Now then I use 90 minus this, so it will be cos 210. Okay, then you check, does these two add up to 90? Now if it adds up to 90, you can press the calculator to verify whether these two are equal. Now take another example. Sine 5 degrees, is it equals to cos 85? Alright, you realize that it is equal. You can press the calculator to check because sine and cosine are complementary trig functions. Another two trig functions that are complement to each other is tangent and cotangent. Okay, now I'm not proving to you, I'm just doing some verifying so that you know what I mean. Alright, sometimes I realize that if I do the actual mathematical proof, some of you might not appreciate, but a lot of you appreciate better if I do some investigation with you guys. Like now, I mean. An example like tangent, you can press the calculator to verify. Tangent 15 degrees, is it equals to cotangent? Now you use 90 minus this. So this should be 75 degrees. Now let's do one more to verify. Now let's say tangent 115, or I make it bigger, right? It's something in the third quadrant, say 210, okay? 210. So this will be 120 minus 120, cotangent minus 120. Alright, you can press the calculator to verify whether what I tell you is true or not. Okay? Now you find that sine and cosine are complementary. Tangent and cotangent are also complementary with each other. Hi, let's move on to try to do an example and make use of what we have learned. Now, given that sine A is equals to 5 over 13 and cos A is equals to minus 12 over 13, find the value of each of them. Alright, these are the various expressions which we need to find their values. Now, what's the purpose of giving us two of them? Now, the purpose is so that we can determine where A is, which quadrant does A belongs to. Okay, let's look at this first. Sine A is positive. If sine A is positive, that means it has to be in the first or the second quadrant, because sine is positive in the first and second. Now, but cos A is negative. Alright, cos A is negative. So, which quadrant can it be if cos A is negative? It can only be in the second and third. Alright. So you've got to satisfy both of these conditions. So in this case, sine A must be in the second quadrant. Okay. Now next, we must draw the triangle so that we can find the value of tangent A. Now must we draw the triangle in the second quadrant? No, it's not necessary. You simply just draw a right angle triangle. And then you have, this is the ratio, alright, the sine function of the ratio of the sine function. So you find that if this is A, now sine is opposite over hypotenuse. It's opposite, so this side is opposite. Hypotenuse is of 13. Okay? Now, so you look at this, you can determine what's the length of this using Pythagoras, or you can simply just look at this. So this is 12. Okay? Or you can use 13 square minus 5 square square root, you will also get 12. So what is tangent A? So the first one, tangent A. Now tangent A is opposite over adjacent. So it will be equals to 5 over 12 according to this triangle. Now, but this is not good enough. This is only the absolute value of it. That means you are not too sure whether this is plus or minus. This is just the numerical value, not disregarding the sign of the value. Now, should it be positive or negative? Now, you look at it, A is in the second quadrant. Now, so tangent is negative in the second quadrant, so it should be minus 5 over 12. Now, let's try to do secant A. So, secant A. Now, what is secant A? Secant is 1 over cos. 1 over cos A. Now, what is A? A is minus 12 over 13. So, 1 over cos A is equals to minus 13 over 12. Okay. Let's move on to 3. Now, in part 3, maybe I just do it over here. Part 3. Now, you are asked to find sine 180 minus A. Now you look at this, what is the basic angle of 180 minus A? Now if A is a cube, it is just simply A. Alright? And you'll find that this is equals to sine A. Alright? This is an identity. If this is in the first quadrant, this will be in the second quadrant. And both of them have the same basic angle. A and 180 minus A, they have the basic angle, which we learned earlier. And if this is in the first quadrant, this will be in the second quadrant. So it's positive. Alright. So sine 180 minus A will be simply 5 over 13. Next, we need to find cotangent 90 minus A. Now what is cotangent 90 minus A? Now we learned earlier sine and cosine are complementary. Tangent and cotangent are complementary. So you look at this, if this is A and this is 90 minus A and they add up to 90. Alright, so this will be equals to tangent A. Tangent A. Now, so what is tangent A? Tangent A is minus 5 over 12. So this is simply minus 5 over 12. Now the last one is sine 2A. Now what is sine 2A? How to find sine 2A? We can use the double angle formula. Sine 2A will be equals to 2 sine of A times cos of A. So we just simply substitute sine A as 5 over 13 and cos A as minus 12 over 13. 13 times 13 is 169. And if you use a calculator, you'll find that the numerator is minus 120. Okay? Hi. In the next lesson, we will be working out the solutions to these two sums. In any case, I'll be putting the URL link in the description below. We hope to see you again. Have a nice day and thank you.